Welcome to the DIY Honda Garage channel. The DTC P1009 indicates a VTC, Variable Timing Control Advanced Malfunction, common in the Honda Accord models from 2008 to 2012. VTC is a system that optimizes engine timing for better performance and efficiency by adjusting the timing of the intake camshaft. The affected components primarily include the VTC actuator, VTC oil control solenoid valve, and the VTC strainer. These components are crucial for the accurate operation of the engine's valve train, which ultimately impacts the vehicle's performance. The VTC strainer is specifically located within the engine and ensures that clean oil reaches the VTC system. When diagnosing this code, it's essential to collect all relevant diagnostic information, including freeze frame data and snapshots, since these can provide crucial insights into the malfunction at the time it occurred. DTC P1009 signifies a malfunction in the VTC Advanced system, which plays a vital role in the overall performance of the Honda Accord's engine. The VTC actuator adjusts the camshaft timing based on engine speed and load conditions, promoting efficient fuel combustion while optimizing power output. The VTC oil control solenoid valve regulates the oil flow to the VTC actuator, affecting the timing modification process. If either of these components fails, it can lead to various performance issues, including reduced engine power or increased emissions. The VTC strainer acts as a filter to prevent debris from entering sensitive engine components. Its location is typically close to the VTC actuator, ensuring that only clean oil is delivered, which is essential for the timely operation of the VTC system. The possible causes for DTC P1009 can include a few critical issues. A clogged VTC strainer can restrict oil flow, impeding the operation of the VTC actuator, which relies on oil pressure for its movement. This obstruction can lead to a situation where the actuator cannot respond correctly to timing requests. A faulty VTC oil control solenoid valve can also lead to improper oil flow control. If the solenoid is not functioning, it will not send the correct oil pressure to the actuator, which can cause erratic engine performance. Lastly, a damaged VTC actuator, which mechanically alters the timing based on the oil pressure supply, can itself fail, leading to inaccurate timing adjustments. Each component's failure can directly impact engine performance, necessitating thorough checks during diagnosis. Symptoms associated with DTC P1009 can lead to noticeable engine performance issues. Drivers may recognize irregularities, such as poor acceleration, where the vehicle does not respond promptly as expected when pressing the gas pedal. This typically indicates that the engine is not functioning efficiently, possibly due to incorrect timing adjustments. Increased emissions could also be a significant concern. The malfunction might cause improper combustion, leading to higher amounts of unburned fuel and exhaust gases being expelled. Moreover, the check engine light will likely illuminate, indicating an ongoing issue that needs addressing. Overall, the combination of these symptoms can result in a less enjoyable driving experience and increased wear and tear on the engine over time. The first step in troubleshooting DTC P1009 is to turn the ignition switch to the on position, also referred to as position 2. Before proceeding with clearing the diagnostic trouble code DTC, it's essential to record all freeze frame data. Freeze frame data captures the engine conditions at the time the fault occurred, providing a snapshot that can be invaluable during diagnosis. It gives mechanics insight into what was happening, such as engine speed, temperature, and other vital parameters of the vehicle at that time. Additionally, reviewing the general troubleshooting information is important before diving deeper into specific components. This overview allows the technician to focus on common issues associated with the code before starting with more complex diagnostics. In this second step, utilize the HDS, Honda Diagnostic System, to clear the DTC from the system. The HDS is a specialized diagnostic tool designed for Honda vehicles and provides both monitoring and troubleshooting capabilities. After clearing the DTC, proceed to start the engine. This action is crucial as it will allow you to monitor the engine's performance in real time and check for any immediate reappearance of the DTC upon restart. Starting the engine after clearing the codes helps gather fresh data directly related to the current state of the VTC system, enabling a more accurate diagnosis of the issue. This step establishes a baseline before further diagnostics take place. Once the engine is started, the next step is to check for any pending or confirmed DTCs using the HDS. This diagnostic tool will list any current codes that may have triggered during the engine's operation. If DTC P1009 is indicated again, it confirms that the issue persists and needs addressing. If it does not indicate the DTC, it suggests an intermittent failure, which may signify that the system is functioning correctly at this point. This step is crucial as it determines whether the problem was a temporary anomaly or if the VTC system still requires further investigation. An accurate reading at this stage helps guide the technician to the next appropriate steps for resolution. In this step, you should turn the ignition switch to the lock position, also known as position 0. This action is necessary to ensure that the vehicle's electrical systems are completely powered down before attempting any mechanical repairs. Following this, remove the auto tensioner from the engine. The auto tensioner is a component that maintains proper tension on the engine's timing belt or chain, ensuring that it functions efficiently. Its removal is crucial for accessing the VTC components that may require inspection. This mechanical disengagement step enables technicians to access the VTC strainer and other components, essential for identifying potential clogs or faults that may be causing the DTC P1009. After removing the auto tensioner, the next step involves removing the VTC strainer from its housing. The VTC strainer plays a crucial role in filtering engine oil to prevent contaminants from entering the VTC system. Inspecting the strainer for clogging is critical, as any obstruction can significantly impact the oil flow to the VTC actuator, possibly leading to erratic timing adjustments. Use clean oil to help assess whether the strainer is free from debris. If the strainer appears clogged, it can indicate a more profound issue, such as contamination in the engine's oil supply. Documenting the condition of the strainer will also assist in determining the necessary corrective actions moving forward. The next action is to evaluate whether the VTC strainer is in satisfactory condition. Assessing if it is clean or damaged is essential. A clean strainer indicates that the oil supply to the VTC is likely unimpeded. If the strainer is clean, proceed to the next step. However, if it's clogged, it needs to be cleaned thoroughly to ensure proper oil flow to the VTC actuator. Additionally, replacing the engine oil filter and changing the engine oil may be necessary to prevent future issues stemming from oil contamination. This dual action can prevent clogging from recurring. Documenting this step is also vital for keeping track of maintenance work performed. In this step, the VTC oil control solenoid valve must be tested to confirm its operation. The solenoid valve directs oil pressure to the VTC actuator, and a malfunctioning solenoid will lead to incorrect oil flow, potentially causing timing issues. Testing involves applying voltage to the solenoid and observing its response, often using the HDS to monitor engine data simultaneously. If the solenoid is functional, you can move on to the next steps. If not, it requires replacement. Documenting the results of this test is crucial as it directs the next steps in the troubleshooting protocol and ensures that subsequent components are not unnecessarily replaced. Following the verification of the VTC oil control solenoid valve, the next step involves inspecting the VTC actuator itself. The actuator is responsible for receiving oil pressure from the solenoid and adjusting camshaft timing. If this component is damaged or malfunctioning, it can cause significant timing discrepancies, leading to the re-emergence of DTC P1009. To inspect the actuator, check for physical damage, rust, or any signs of oil leaks that may indicate internal failure. If found to be okay, you would proceed to inspect the oil passages in the VTC system. Any blockage there may also lead to problems. Documenting the condition of the actuator provides a basis for understanding any further issues that may arise. Once the VTC actuator has been checked and cleared of issues, the next step is to investigate the VTC system oil passages. These passages guide oil flow throughout the VTC system and contribute significantly to its functionality. Any blockages or restrictions within these passages can lead to faulty operation of the VTC system, which would directly contribute to code P1009. Cleaning the oil passages is essential if any contaminants or debris are found. Ensuring that the oil flow is optimal for the actuator's operation. This cleaning should be done carefully to avoid introducing additional debris into the system. Documenting the condition and any cleaning measures taken is important for proper record keeping. After ensuring all components have been checked and serviced, turn the ignition switch back to the on position 2. The next vital action is to reset the engine control module, ECM, or powertrain control module, PCM, using the HDS. Resetting the ECM, PCM clears any stored faults and initializes the engine control system to baseline conditions. This reset is essential after any repairs or adjustments to ensure the computer system accurately monitors the vehicle's current operational state. Following the reset, you will proceed to conduct the ECM-PCM idle learn procedure, which assists in updating the module's adaptive learning values for optimal engine performance. In this step, perform the ECM-PCM idle learn procedure after resetting the computer. This procedure helps recalibrate the ECM-PCM's parameters to optimize engine performance by learning the engine's idle characteristics. After completing the idle learn, conduct a CKP, crankshaft position pattern learn procedure. This is critical for synchronization between the crankshaft and camshaft positions, ensuring accurate timing. Both procedures are designed to enhance the overall operation of the vehicle post-repair and should not be skipped, as any inaccuracies can lead to performance issues or the reoccurrence of faults. Record any changes noted during these procedures for future troubleshooting reference. Finally, after executing all previous troubleshooting steps, check the vehicle for any pending or confirmed DTCs again using the HDS. If DTC P1009 is indicated once more, this shows that the problem persists and requires further troubleshooting. In this case, you should return to the point in the process where you began and continue to inspect the oil passages in the VTC system closely, as they can be the source of continual obstructions or malfunctions. If no codes appear, the troubleshooting efforts may have resolved the issue successfully, but it's essential to monitor vehicle performance closely moving forward. Thorough documentation of this final diagnostic step is crucial for maintaining service history. Before concluding the repair process, a final verification is crucial to ensure that all repairs associated with DTC P1009 have been completed thoroughly. This includes confirming the replacement or cleaning of components, like the VTC strainer, solenoid valve, and actuator, as well as ensuring that all oil passages are free of debris. Following this confirmation, it's important to verify the vehicle's performance on the road. Observing how the vehicle behaves under different driving conditions will help determine if the issue has been adequately resolved. Ideally, the vehicle should exhibit smooth acceleration and consistent engine performance. Documenting this verification step is vital for future reference and customer satisfaction. Preventive maintenance plays a key role in avoiding future occurrences of DTC P1009. Regular oil changes are essential, as clean oil ensures that the VTC system functions optimally without clogging from contaminants. Monitoring the condition of VTC components can help catch potential issues early before they escalate into major problems. It's advisable to include checks on the VTC strainer, solenoid valve, and actuator during routine inspection intervals. Keeping an eye on engine performance also allows for prompt action should any symptoms arise again. Preventive maintenance is not only cost-effective, but also significantly extends the lifespan of vehicle components while enhancing overall performance. In conclusion, understanding DTC P1009's significance is vital for Honda Accord models from 2008 to 2012, as it directly relates to VTC system performance. Following the outlined troubleshooting steps methodically allows for a comprehensive diagnosis of the issue, ensuring all potential root causes are evaluated. Emphasizing preventive care through regular maintenance can help avert future problems related to the VTC system and maintain optimal engine performance. By systematically addressing the code and ensuring proper repairs, technicians can enhance the driving experience and longevity of the vehicle. Keeping detailed service records and understanding the vehicle's operational conditions will assist in the timely resolution of any new issues that may arise in the future. Please like and subscribe to the channel. See you next time!